Okay, so 16J, sketching sine graphs that have been translated horizontally and vertically, and cosine graphs that have been translated horizontally and vertically. So same as always, A is the amplitude, 2 pi over n is the period, h moves it horizontally, and the only thing that has changed is we've added a k. So k moves the graph. Vertically. Same as always, if it's a positive k, then it's moving up. If it's a negative k, then it's moving down. H is the one that's opposite. So we'll go straight into an example because I think this one's easiest to learn when you're actually doing it. So sketch y equals 3 sine 2 t minus pi on 4 plus 2 for t between pi on 4 and 5 pi on 4. What's our amplitude?
3.
Yes, it's 3. So from the middle of the graph up to the top of the graph is 3 units. What's our range? Think about it carefully. What is it? What is it usually? It's usually negative amplitude to the amplitude. So it's usually negative 3 to 3, but we've actually moved this graph up by 2. Yeah, so it's going to be negative 1 to 5. So maybe up here I will say the range is now, it'll be negative a plus k and a plus k. Because you're moving it vertically, so the range is changing. Okay, what's the period? 2 pi over n. N is our 2, so you get 2 pi over 2. So that's pi. Okay. Now we've got to solve for the y-intercept and the x-intercepts. Well, technically we don't need a y-intercept because we're starting from pi on 4, so we'll skip that. Let's find the x-intercepts. Or maybe if we sketch it first, it might make it a bit clearer. So we'll sketch it. Going from negative 1 to 5, so we'll draw it like this. So that's t, and that's y. Negative 1, 5. Where's the middle of our graph going to be? It's halfway between negative 1 and 5.
2.
Yes. So we're going from quarter pi up to 5 pi on 4. So we'll make this 5 pi on 4. Maybe we'll... It's right, you don't have to rub it out. I'm just going to make it more accurate. So if I make this one pi, then that'll be half, that'll be a quarter, that'll be a quarter, and that'll be another quarter. So this one's pi, this one's 1 1/4, this one's half, this one's quarter, and this one's 3/4. Yep, so this is 2 here. So it usually starts down here, but it's been moved pi and 4 to the right and 2 spaces up, so it's going to start here. And you know that it's going to go through a full pi, because the period is pi. Yeah, it's going to go through full pi before it starts again. So it's got to go up and then back down and then back up. So it's going to end here. It's going to come back through our middle line exactly halfway between those start and end points, which is going to be here. And then it's going to reach its maximum halfway between the first 2 points and reach its minimum halfway between the second 2 points. Like normal. And then all you got to do is join them up in kind of a curvy pattern. Right, I also want to say for your tests, when you're drawing lines, try to draw them as straight as possible, right? Imagine that this is a graph that you've drawn on your test. They don't look like this. Right? Lines do not look like that. I've seen that far too many times, right? Sketch it first in pencil, and then if you want to, you can go over it in pen, because that is not a line, right? That's about 10 different lines. Right, so always just draw them as a single line. Right, now all you have to do, finally, is work out the 2 x-intercepts. Because we draw a graph, we want to know all the important points, and 2 important points on this graph are the 2 x-intercepts, which are here and here. How do we find x-intercepts? No, don't think about sine graphs. Think about normal linear graphs. How do you find an x-intercept? Make y equals 0. So we get up here 3 sine 2t minus pi on 4 plus 2 equals 0. Now we're going to rearrange as much as we can. We're going to take over that 2 first and then divide by 3. So we took over the 2, get negative 2, and then we divide by 3, we get negative 213, 2/3. Right, now we're going to use what we learnt in 16i and try and find the angle for which it gives us negative 213. So we're going to take this sine over, it becomes inverse sine. It's just some rearranging. Is there any triangle that we know of that gives us 213 when it's sine? No, so then it would be just a calculator question. So grab your calculator out, work out the angle for inverse sine of negative 213, or just regular 213, positive, because then we use our symmetry to figure it out. Yep, so we get 2t minus pi on 4 equals, we have to work out with symmetry first. So we get 0.7297. Right, that was for inverse sine of 213. And now with our symmetry, Sine is y value. 2 on 3 is up here. Remember doing this 16i? Yeah?
Use a negative of that though.
Oh, sorry, yeah, sorry, yep. Negative 2 on 3, not 2 on 3. Get rid of that. Negative 2 on 3 is down here. Here and here. So we know that this angle in here is this, 0.7297 radians. This down here is pi plus the angle, and this one is 2 pi minus the angle. So all you have to work out is pi plus 0.7297 and 2 pi minus 0.7297. Okay, cool. So we're on the right track. 3.87 and 5.55. And now all we've got to do is rearrange to get t on its own, and that'll give us the solutions to the x-intercepts. That's the bit we were missing. So then you've got to divide both your answers by 2. So you get t minus pi on 4. Right, so on the calculator, do your 3.87 divided by 2, 1.9, and 5.55 divided by 2. Make sure you use your unrounded answers, not just 5.55, because it'll make it a little bit out. 2.78. And then all you got to do is add pi on 4 to both. So 1.94 plus pi on 4. Don't worry, you won't be asked to do anything like this without a calculator. Is that 2.72? And that one plus pi on 4 equals 3.56. And that's simply just adding pi on 4 on the calculator. Do those two solutions make sense for our x-intercepts? Yes, so 3.56 is a little bit above pi, and 2.72 is a little bit below pi. So this one is 2.72, and this one is 3.56. Squeeze it in there. Right, so keep in mind you can do your answers in decimal form. It's perfectly acceptable. Obviously, if you can do them in exact form with pi, then that's good, but sometimes you just can't. Yep. Cool, so second one, sketch y equals 2 sine 2 x minus pi on 3 minus root 3. For x between 0 and 2 pi. Right, so amplitude, what is it? Good. Range? Negative amplitude plus, right, negative root 3. And positive amplitude plus negative root 3. So that gives us negative 2 minus root 3 and positive 2 minus root 3. Which, don't freak out, it's just a number. Root 3 is some decimal. Take that away from 2 and negative 2.
That's all right. We do that as decimal, but like actually get one number. Is that all right? Or
you can estimate it. Like, you don't need to know the exact position of it. Yeah. What's the period? It's pi again, yeah. 2 pi on 2. which is pi. Okay, let's go ahead and draw it. So this time it's x and y. Right, where's our middle line? Well, our range is from 2 minus root 3. What's that roughly? 2 minus root 3. 0.27. So we'll go here. And then negative 2 minus root, oh, close, negative 3.73. So we'll say that's down here. Okay, so our middle line is going to be where? It's actually super easy. The middle line is always just the k value because it's originally on 0, and if you're moving it down negative root 3 spaces, the middle line is going from 0 down to negative root 3, yeah. So if you want to write yourself a little note where the middle line is, it's just at the k value. So that's negative root 3 there. Okay, where does a sine graph usually start? Oh, before we do that, we need to make our x-axis intervals. So we're going from 0 to 2 pi. So we'll make 2 pi over here. Halfway to that is pi. Now looking at the question, we've got a pi on 3, so we probably want to split it up into thirds rather than halves. So I'm going to split it into thirds. So that's pi on 3, 2 pi on 3, 3 pi on 3, 4 pi on 3, 5 pi on 3. Right, sine graph usually starts at the origin, but it's been moved to the right pi on 3 spaces and down negative root 3 spaces. So it usually starts here, I'm going to go across and down starts here. Okay, then what? Then what do we do? We need some more points before we draw it. Yeah, you can. We usually draw the basic shape and then you can probably find the intercepts, but there's nothing stopping you from doing it the other way around.
Do we mark where they are?
Right, what's the period? So it's going to go through a full cycle before it starts again. So where's it going to end? We know that it starts at pi on 3 and it goes through a full pi. So it's going to end here. It's going to go through the middle halfway between those. So it's getting quite complicated because we don't have enough points. What are we going to do? Let's split it up into 6. So 1, 2, 3, 4, 5, 6. Yeah, so let's split these up again. That might help you.
I want to put in numbers.
Well, you can. That'd just be pi on 6, 2 pi on 6, 3, so that's a half. So that's pi on 2. That's pi on 6. It just gets a little squishy. So 1, 2, 3, 4, 5. 5 pi on 6. 6, 7. 7 pi on 6. 8, 9, which is 2/3. Wait, 9 pi on 6 is 3 halves. Yeah. 3 pi on 2. 10, 11 pi on 6. Okay. Why do you do it? Just to make it easier to see where it hits that maximum minimum point.
Is that all we did?
Yeah. Because we know that it's going to hit this maximum line between these first 2 points. So it's going to be halfway between half pi and 2/3 pi. Okay. How do you find the midpoint of 2 points? Yes, add them and divide by 2. So you can find that point there just by adding pi on 2 and 2 pi on 3 and then dividing by 2. Okay. All right, it's going to hit its minimum line halfway between these two, which is halfway between pi and 7 pi on 6. It's going to come down here. All right. So it's going 1.5 intervals between like each point. So if we go back this way, 1.5, it's going to hit its minimum down here and then kind of come back up. So going down, up, right, 1.5 spaces, it's going to come up to the maximum. 1.5 spaces, it's going to come back down to the line. And then 1.5 doesn't quite reach, it's going to end somewhere down here. Right, so let's kind of join them up. Whew. May not be super accurate because we haven't found the x-intercepts yet. Maybe Shirley's right. Maybe you should find the x-intercepts first so you know how to plot it exactly. It depends on how you want to do it. If you want to draw the line first so you see a rough estimate of where the intercepts will be and then you can test your answer against that, or if you find the x-intercepts first so you know exactly where they'll be and kind of trust that answer and plot them, and you can join the line up more accurately. It just depends on which way you feel more confident. Right, so we know that there's going to be, because we've drawn the line from 0 to 2 pi, that's why we kind of kept going all the way to here and then all the way down to here. So we're going to find the y-axis intercept and the x-intercept. So how do you find a y-intercept? Yes. So we get y equals 2 sine 2, 0 minus pi on 3 minus root 3. So that's 2 sine 2 pi on 3 minus root 3. What's sine of 2 pi on 3? Where's 2 pi on 3?
Would it be negative sine of x?
We S, right?
S, the S equals
Yes. S where it stops.
S,
negative
where it stops.
All of
1, 2. Here? Yeah. All right. Missed something. That's a minus pi on 3, so it should be negative 2 pi on 3. Right? So, right, if we know that this angle is 2 pi on 3, what's this angle here? It's pi on 3. Pi on 3, we got root 3, we got 1, we got 2. So what's sine of 2 pi on 3? Sorry, no, sine of pi on 3. Opposite over hypotenuse. Where'd the what come from? Yeah, sorry, it's a negative 2 pi on 3. So it's actually, let's start this one again because it's a bit confusing. Draw it a bit bigger. Right, negative 2 pi on 3. So we go the negative direction down here. 2 pi on 3. Right, it's in the third quadrant. We can figure it out. We've got pi on 3 here. So if we figure out what sine of pi on 3 is, then we'll just do pi plus pi on 3. Unit circle stuff. So yeah, we got, let's do our pi on 3 triangle, 1 and 2. Sine of pi on 3 is opposite over hypotenuse. Oh, we don't even need to do pi plus pi on 3. That's for the angle. We want to know the actual value, which we just use our all stops to Caulfield. All stops to Caulfield. Is this answer going to be positive or negative in this quadrant? Negative. Right, so that's 2. Sine of negative 2 pi on 3 is negative root 3 on 2 minus root 3. Still following? It does get tricky, but just with practice it gets easier. Right, so then you multiply in that 2. We get negative 2 root 3 on 2, which is just root 3, minus root 3, which is negative 2 times root 3. Amazing. So this point here is actually negative 2 root 3. Yeah, I know. It does take a while when you don't have a calculator. Okay, now we've got to find the x-intercepts. It's not over. So let's just wipe this out. Can you use what? Discriminant? No, it's not a quadratic. Right, now, how do we find x-intercepts? Make y equals 0. So we got 2 sine 2x minus pi on 3 minus root 3 equals 0. Let's rearrange a little bit. So we're going to take over that root 3 and divide by 2. So we took over the root 3 and we divide by 2. Now obviously you take over the sign, make it inverse sine of root 3 on 2. So now we have to think what angles, when it's sine, give root 3 on 2. We've already worked that out in the last step. It was pi on 3. But because we're going to be dividing by this 2, you need to make the domain double the size. So we need to go from 0 to 4 pi because there's going to be 1, 2, 3, 4 solutions. Right, so let's draw our unit circle. So we know that it's pi on 3 out there. Okay, and because of symmetry, we also get that one out there. And we're going around twice from 0 to 4 pi. Yep. Okay, so this one is pi on 3. What's this one going to be? 2 pi on 3. Yeah, or you can do pi minus pi on 3, which is just 2 pi on 3. Yeah. So we also have 2 pi on 3. Now if we've got to go all the way around, we get 2 pi plus pi on 3, which is 7 pi on 3. So let's just write these in. We're getting pi on 3, 2 pi on 3, 7 pi on 3. Oops, not an 8. 3. Keep going. We're all the way around. 2 pi, 7 pi on 3, 8 pi on 3. Okay. Now we need to rearrange to get x. So you're going to divide each solution by 2. Pi on 6. 2 pi on 6, which is pi on 3. 7 pi on 6. And 8 pi on 6, which is 4 pi on 3. So that was after we divided by 2. And now you need to add 3 pi to each of them to get your final solutions of x. Yay! Which you actually run out of room. So where can we squish it in? Up here? X equals, right, what's pi on 6 plus pi on 3? Adding fractions. Common denominator.
Pi on 6.
Well, we make the pi on 3 into a 2 pi on 6.
Yes.
So we get pi on 6 plus 2 pi on 6 is 3 pi on 6, which is pi on 2. 3 over pi on 3 plus pi on 3 is 2 pi on 3. They're here. There and there. They're the x-intercepts. Yeah. Okay, 7 pi on 6 plus 2 pi on 6, 9 pi on 6, which is 3 pi on 2. Right, it's just adding fractions at this point. 4 pi on 3 plus pi on 3, 5 pi on 3. Right, so we get pi on 2. Well, that's already done for us. That's that point. 2 pi on 3. That's already done for us. It's that point. Oh, see how these are matching up? 3 pi on 2. Our scale was a little bit off. It should have gone through that line. So let's fix that up a little bit. So it actually should come through that line and then through that line. There you go. It all worked out in the end. Easy peasy.
How many marks would that be?
Oh, like 6, 8.
Really?
No,
About 12?
I'll have to double check what I did on the test.
Can that be the whole test?